Alright, let's talk about number 4 from the 2015 Calc AB and BC exams. It's a slope field slash differential equation problem. And so the first thing we need to do is create a slope field, which is kind of an awful experience. So dy dx equals 2x minus y, and we have 6 points. So let's just do it. Basically what you do is you take the points on the grid, plug them in, get a slope, go to the point on the grid and draw a little tiny line segment with that slope. So some of them are kind of hard to aim. This one's not so bad. I'm aiming at the point 1, 0 as I draw that. That'll give me a slope of 1. At the point 1, negative 1, I get a slope of 3. So that one's hard. It's got to be more extreme. So what I really did was I aimed for I don't know, I estimated what I thought a third of the distance was, and then I went up, I don't know. More extreme is what you're going for. At the point 0, 1, our slope works out to negative 1. That one's easy because you just aim for 1, 0 again. When we get to 1, 1, we get a slope of positive 1. So if I aim for the origin, 0, 0, that'll give me a slope of 1. At the point 0, 2, I get a slope of negative 2. So if I aim for the point 1, 0, that point is coming up a lot. That'll give me a slope of negative 2. And then at the point 1, 2, I get a slope of 0, which obviously just go horizontal. And we get that. So that's your slope field. I don't really know what you're supposed to get out of that. But let's move on to the next part, in which we are asked to find the second derivative of this thing in terms of x and y. So this is a pretty common question. So it involves a little bit of implicit. So the second derivative, the derivative of 2x is 2. The derivative of y is dy dx, so I get 2 minus dy dx. And then I want my answer in terms of x and y, so I'm going to replace dy dx with the quantity 2x minus y and distribute. And there's my second derivative in terms of x and y. Alright, so this question has an added part that talks about, asks us to find concavity of the solutions in the second quadrant. So think about the second quadrant, and you know that x is less than 0 and that y is greater than 0. And knowing those two things, that's a useful combination of things to know, because if x is less than 0, then looking at the second derivative, negative 2 times a negative number is a positive number, and y is greater than 0, so y is a positive number. So we have 2, a positive number, and a positive number, so we can conclude that the second derivative is greater than 0 for all solutions in the second quadrant. So every ordered pair in the second quadrant generates a positive second derivative, so we're concave up. So let's write that out. So second derivative is greater than 0, means that the solutions are concave up in the second quadrant. And that's how I'd answer that question. The next one talks about a particular solution, but we don't need to find the particular solution. So we are given the point 2, 3. Well, we're told f of 2 equals 3, and asked for whether f of x has a maximum, minimum, or neither at x equals 2. So I'm just going to substitute in 2, 3, and I get 4 minus 3 is 1, which is not equal to 0. So since the first derivative is not equal to 0, we are not going to get a maximum or a minimum at the point 2, 3. And that's kind of interesting, because I don't remember a time on the AP test prior to this where you didn't get a maximum or minimum. So I don't know, maybe they're changing that up a little bit. So in the future, I guess you can not take for granted that the first derivative is going to be 0. And then let's take a look at part D. So we are given this, and we're also told that y equals mx plus b is a solution to this differential equation. So I kind of like problems like this. So the first thing I'm going to do is I'm going to use y equals mx plus b to find another way to write dy dx. So if I take the derivative of that, I get dy dx equals m, which means if I look at both ways of writing dy dx, I can actually just say that 2x minus y is equal to m, which is useful. And then I have 2x minus y is equal to m, but I actually have two ways of writing y. I know that y is equal to mx plus b. So I'm going to say 2x minus the quantity mx plus b is equal to m. I'm going to work on that left-hand side a little bit. So 2x minus mx minus b equals m. Let's move up here. I'm going to factor a tiny little bit. You get this. And then there's no x on the right-hand side, so I'm actually going to add in a 0x. So I have 0x plus m. So I have the quantity 2 minus m, x, minus b equals 0x plus m. Now I'm just going to equate coefficients. So 2 minus m must equal 0 because those are the coefficients of x. And so that tells me that m is equal to 2. And then looking at the things that don't have x's, so negative b must be equal to m because these two things are equal to each other, which means that b is the opposite of m, so b is negative 2. And those are the values of m and b. I hope you found this helpful, and good luck.